Hello, folks. My name is Samartha Chandrasekhar. I'm a product management lead at Snowflake. And today I'm here to walk you through a number of tips and tricks that can help you optimize your Snowflake spend. This session is tailor made for builders and it's going to be demo heavy. So I'm going to walk you through a number of demos that showcase our latest capabilities that can help you optimize your spend and get the best bang for your buck for all that you spend on Snowflake. For today's agenda, we have a few exciting things to go over. The first one is I want to walk you through an overview in terms of the components of Snowflake cost. Next, I want to walk you and familiarize you with our cost optimization framework. And then, using the aid of demos, I want to walk you through specific capabilities that we have for cost visibility, for cost control, as well as tools to help you optimize your spend. And then finally, we have I'd also like to provide a sneak peek into some upcoming new functionality that hasn't fully launched yet. Starting out, I'd like to walk you through the components of Snowflake cost. There are really three primary components here. There's compute, there is storage, and networking that we allude to as data transfer. The compute component is typically responsible for the vast majority of most Snowflake accounts spend and their bill itself. And in the compute component, the most important and impactful part to spend is virtual warehouses, which represent Snowflake's primary compute primitive. This is essentially an elastic, instant on, scale to zero compute primitive that we price or we bill you for only when you use it on a per second basis. This is where all of your queries, all of your Python programs, all of your Java programs run. Cloud services is another compute artifact here, which represents essentially the connective tissue that helps realize the Snowflake distributed system. Things like query compilation, things like result caches, things like show commands are all run in this cloud services component. And the important thing to note here is we subsidize the cloud services cost footprint up to 10% of daily compute, which is essentially your daily warehouse cost footprint. And it's actually extremely rare to see a line item for cloud services. It's a small minority of our customers that actually see this line item. But in the interest of completeness, it's important to call this out. Then thirdly, we have a collection of serverless services like query acceleration, automatic clustering, search optimization, materialized views, etc., that help with both price and performance. And again, these also come with a per second billing model. The other two components, storage and data transfer, are typically smaller fractions of the customer bill. We have a pass-through pricing model for both of these, which is that whatever we incur from the cloud provider, we try and pass this on. Specifically of note is in the case of storage, what you get billed for is the compressed storage volume, not the uncompressed one. And we have a best-in-class compression mechanism that has been shown to compress your data up to 7 times. The data transfer and egress fees, again, are cloud provider fees that we essentially transfer on. This is typically things that customers see when you run copy commands or when you're using replication functionality to replicate Snowflake functionality across multiple cloud regions or sometimes even across cloud providers. I'd like to walk you through Snowflake's cost optimization framework. At a high level, we've organized our capabilities into three distinct buckets: visibility, control, and optimization. Visibility alludes to the collection of capabilities and features that we have that helps customers monitor, attribute, and understand their spend. Control alludes to capabilities to actually limit spend and set sort of hard caps. Optimization refers to a bouquet of capabilities that helps customers understand inefficient or suboptimal or low yield spend and mechanisms to go reduce that. Next, I'd like to walk you through sort of each of these capabilities, or rather a subset of some of these capabilities, through the aid of demos. Again, this will not be exhaustive. I have exclusively cherry picked some functionality that I think is representative and would be useful for you to know about. Starting with visibility, I'd like to show you a demo of our UI based cost exploration experience. So at Snowflake, our intention is to give you a full overall view of your spend, starting from your organization level spend, account level spend, to individual credit consuming artifacts. So what you're seeing right now here is a usage view for one of my test accounts. one of the things that you'll notice is it gives me a visual representation of my spend over the duration that I select. In this case, I've selected the last 28 days. What you'll also see is a cumulative listing of various artifacts, along with sort of the trends associated with usage that I can monitor with a quick glance. I can also go ahead and tag individual credit consuming artifacts with specific cost governance tags that mark it against specific cost centers or projects or environments. In this case, I have a tag for a cost center equals finance. So I can actually go click on this and go look at all of the spend associated with this specific tag. And this is super instrumental in terms of actualizing showback or chargeback mechanisms where specific sources of spend can be earmarked and tagged to represent specific cost centers. And it also helps me organize my analysis of this spend here in in an easy to understand manner. The other thing that I think here is noteworthy, if I can go back, is I can also group um, these credit consuming artifacts based on compute, storage, or networking, which is data transfer. So in this case, I've selected compute, but I could also go look at sort of the cumulative estate of my spend across all types of resources. So what you see here is now the cumulative spend across all resource types. I can do the same thing for storage and data transfer, and we'll get the filtered results for just that. Furthermore, this is at an individual account level, and you can look at the spend associated with specific artifacts. What I can also go do is, if I have organization admin or org admin privileges, I can go look at all accounts and look at sort of the entire estate of my Snowflake usage across the multiple accounts that have broken out my usage into. So what I see here is exactly that. So this color coding essentially shows me a breakdown on a per account basis. And again, the it'll also show me the service level for individual accounts, the usage trend, the individual cost, footprint associated with each of those accounts during this time period that I've selected. So this is a quick overview of our UI-based cost exploration experience. I think the top takeaways here are: you can do this at an account level, you can do this at an organization level, you can filter by resource types, compute, storage, data transfer, and egress, as well as the ability to selectively tag specific resources, associate those tags with a specific cost center to help actualize a granular chargeback or showback model, especially if you're using shared resources. Next is control, which is a bunch of capability to help you limit spend. Now, again, the span of capabilities under this umbrella is quite large. Things like warehouse size, warehouse type, number of clusters in a warehouse implicitly provide some level of spend control within Snowflake. Now, over and above that, there are two specific noteworthy capabilities that I'd like to walk you through. The first one is called resource monitors. So this is a mechanism that essentially sets hard limits to prevent overspend. Resource monitors are stipulated at the granularity of individual warehouses, and you can set behaviors to either alert based on when a certain spend threshold is reached, or you can actually go further and actually suspend that warehouse if a certain spend threshold is reached. And it offers sort of the ability to have permutations of these capabilities. You can alert and suspend, or only suspend, only alert, etc. As the graphic here shows you, you can also set percentages for credit burn to trigger some of these actions. It is super. We highly recommend that you set resource monitors for all, if not most, of your warehouses. And one of the things that I'd like to show you is this best practice in action. Some time back, we published a blog post that goes over compute primitives in Snowflake and provides a bunch of best practice guidance in terms of things that we recommend that you do to optimize your credit spend. As a part of this, we have a collection of queries. And one of the queries that I'm going to show you, show running right now, is a query that identifies warehouses without a resource monitor set. So I've copied this query here, and this is the query that I have. As you can see, it says where resource monitor equals null. It's going to show me all of those warehouses, as well as details around the size of those warehouses. So this query is running. Now this is the test account that I have. Let's see what shows up here. So this query just returned this list of warehouses. It is a test account, so we have lots of warehouses without resource monitor set. Now, if I were a Snowflake admin, if this were a a real production account, I would be going and following up with the individual owners of these warehouses. Or if I had the ability to set it myself, I would be going ahead and setting resource monitors here for each one, so that you might not be able to suspend or throttle, but at the very least, alerting is benign capability that we highly recommend that you at least go set up. One of the other control capabilities that I'd like to walk you through is what we call auto suspend and auto resume. This is a capability that we typically like to call a scale to zero, which is that our virtual warehouse, when there isn't any work that's running inside of it, can go to sleep, and you don't pay anything while the warehouse is suspended or sleeping. And then when work comes back in, it can automatically resume without you having to do any work, thereby spinning it up near instantly and enabling queries to run. Now, the important thing to note here is that auto suspend capability is enabled by default. So without if you don't go change that, it's always enabled. Um, the other important thing here to note is that there's actually some nuance with respect to what your auto suspend timeout ought to be. Typically, a virtual warehouse, which is essentially a collection of virtual machines with a certain amount of RAM, with a certain amount of local SSD in an internetwork mesh running different query artifacts, um, provides a lot of benefits through caching, through using both the main memory, the RAM, as well as the local storage, the secondary storage associated with that. Now, if a warehouse suspends, though the contents of those caches are invalidated, and uh, when a new query runs after the warehouse resumes, it'll have to operate from a place of an empty cache. So this auto suspend timeout essentially lets you stipulate and provides you with some control in terms of you know the amount of time a warehouse continues to run until sort of it goes to sleep, assuming there is no work coming in. So by default, this is set to 10 minutes, but there are categories of use cases where we recommend setting it to a different value. For example, if you have an ETL or an ELT use case, which typically do not benefit in any way from the existence of the caches, or there is no need to keep the caches warm, we actually recommend and going and setting the auto suspend timeout to immediate, which means that if there is no query that's running, if there are no jobs that are running, the warehouse immediately goes to sleep, in which means that you're not paying for any of the compute because there's no useful work being done. Similarly, there are also use cases on the other end of the spectrum, such as BI use cases, such as dashboarding use cases, where the benefit of caching can actually play a substantial role in terms of improving overall price performance. And for such use cases, we actually recommend the default, which is 10 minutes, which means that the warehouse is running for at least 10 minutes until after the last query runs before it goes to sleep. Um, and of course, there are sweet spots in between. So, for example, we know of lots of data science and data ops use cases where probably the ability to benefit from caching is somewhere in between these two extremes. And for those use cases, we recommend 3 to 5 minutes, typically 5 minutes, in terms of what you can go set. The other anti-pattern here to be mindful of is to set the auto suspend value to be some sort of an egregiously high value. And we've seen this mistake happen across a large number of accounts. And one of our best practice guidance here to help with cost optimization is to ensure that you're actively aware of what the auto suspend value is for various warehouses, and you're explicitly aware of the outliers here, the ones where the value is set to an what could be argued to be an egregiously high value. So to show you that, another best practice that we have in this blog that we put out is a query to identify you know warehouses with auto suspend values that are probably too large. And so I'm going to run one such query here that I've sourced from the blog that I alluded to. And in this case, we're saying that 1 hour, which is 3600 seconds, represents what is like a high enough value to the point where it's worthy of a second look. So I'm going to run this query, and this is going to return all of the warehouses in this specific account with this very high auto suspend value. And as you can see, this is a test account, and so there are a bunch of demo warehouses, test warehouses, etc., where it's set to a value that is greater than 3600 seconds. And so this is a launching point for further investigation to either go reduce that, or to if there's a good reason to have it there, that's fine. But this is certainly a good filter to kick off certain investigations. The next capability that I'm excited to show you is something that's called budgets, which is a capability that's in public preview that we're very excited about. This is functionality that can essentially help monitor, track, and to a certain extent limit spend. So you can set a budget at the granularity of either an account or on a custom grouping of credit consuming resources. And while you create a budget, you can also stipulate sort of an end value for that budget, which is sort of the spend limit to monitor. And based on the current credit burn rate, based on the trajectory of spend, we not only reactively alert once the budget threshold is breached, but also based on whether you're on course based on the current trajectory to exceed the budget. Based on that, we actually proactively send out an alert. In what we currently have, we send out an alert uh, no more than once a day if the trajectory that you're on has you exceeding your monthly budget. So what you see on your screen is the budgets UI. um, like I said, there are two levels at which the budget can be set. There's a spending limit, aka a budget, that can be set at the account level. So for example, I can go modify this. You can set a budget at the level of an account or on a custom grouping of credit consuming resources. What you see here is me editing the account level budget. Now, to assist with setting this budget, I also get some informationals around um, the current trajectory, what the trajectory holds in terms of the cumulative credit consumption at the end of the month, as well as sort of the average over the past 3 months, which can help inform me to set this budget. So I can set this budget, set up an email notification uh, uh, that where notifications are sent if the budget value is exceeded, or if the current trajectory that I'm on um, is one that has me exceeding the budget value. Now, the other important thing here to note is the visualization that we have. So in this specific case, the budget was set in the middle of the month, and the the bars that you see in the lighter shade of blue represent the usage, and then the the bars that you see in the darker shade of blue are the parts that are governed by the budget. This is when the budget got set. And you can also see the trend lines here in the trajectory. You can also see what fraction of the budget has been spent so far, as well as what fraction of the budget duration, a month in this case, has elapsed. So in this case, we're done with 29 out of the 30 days, and we have some headroom left in this illustrative example. Now, this is at the account level, and this account level budget includes all credit consuming resources in that account. This is warehouses, this is cloud services, this is serverless artifacts, everything. Now, the other important thing that I'd like to show you is custom budgets, where I can go ahead and create um, a custom budget, and I can say, I can stipulate my own spending limits, and I can select a custom grouping of my credit consuming resources. So in this case, I'm going to select, let's say, these two databases, and maybe I also go select or I selected a few warehouses, and now maybe I just go select a bunch of test databases as well, and then I go provide my email address, and this goes ahead and creates this budget. I call it test budget 3. And based on the usage footprint, I can also get a similar view, which I'll show you in just a little bit, that visualizes the current spend, um, the way it's trending, as well as where the limits are for this custom budget that I've created based on this custom selection of credit consuming resources. The important thing to note here is that a given credit consuming artifact, like a warehouse, a database, etc., can be a part of one and only one custom budget. It is also going to get included at the scope of the account level budget, but for custom budgets, it's going to be no, one budget only. So we have another test budget here, and the credit consuming artifacts that were selected for inclusion in this test budget were things that actually have accrued towards a lot of spend, and the test budget value that we set here has been breached, which is what is shown here, and this would have been accompanied by a large number of email notifications as well. So that shows you the budget functionality in a nutshell. This is a capability that's in public preview that we're working hard to take to GA in due course. Now, moving to optimization. The most important thing that I'd like to highlight here is that Snowflake is constantly providing transparent platform improvements behind the scenes that benefit your usage of Snowflake without you having to do any useful work, such as opting into specific capabilities or upgrading, etc. You can be beneficiaries of these platform improvements that Snowflake is delivering on an ongoing basis. We also have this modality that we call SPI, Snowflake Performance Index, that actually quantifies the benefit of the transparent platform improvements. It could be moving to a new VM SKU. It could be updates to our compiler. It could be updates to our query runtime, etc. That actually quantifies the extent to which it is helping with your cost efficiency. Now, for today's optimization exercises, I'd like to focus on two specific capabilities. The first one is called Snowpark Optimized Warehouses, which is a special warehouse type with disproportionately large amounts of RAM and local disk. What this means is that if you have high memory analytics use cases that can't properly fit or function in a standard warehouse, a Snowpark optimized warehouse will likely address that. This includes things like ML training on large amounts of data. It includes things like in-memory analytics, or sort of memory intensive analytics that um might result in a phenomenon that we call spilling in Snowflake, which means that the memory needs of the workload weren't entirely sufficed by the local memory available in the warehouse nodes, and thus, we had to go access either the local disk associated with each VM of the warehouse or to object storage, such as S3 on AWS. Now, if you look at the memory mountain, it's much faster to many orders of magnitude faster to to read and write something to RAM as opposed to local disk, as opposed to object storage. And this is where Snowpark optimized warehouses play a big role. One of the most important things here is that we actually expose metrics such as the number of bytes spilled to disk, the number of bytes spilled to object storage, etc. And Snowpark optimized warehouses can help with speeding up some of these workloads, which can, in some cases, provide drastic improvements to price performance overall. What I'll show you here quickly is a query that I have. It's also documented in the blog post, and there's a bunch of content around that explains sort of how a Snowpark optimized warehouse works, what's special about it, etc. But what this query is doing here, it's looking at the number of bytes built to remote storage, which in this case is S3, which is Amazon's simple storage service, since this test account is running on AWS. So once this query executes, you'll notice that I see a large number of warehouses here. These are all standard warehouses that are seeing spilling, and these are potentially candidates to upgrade to a Snowpark optimized warehouse. The important thing to be mindful of here is that a Snowpark optimized warehouse costs 1.5 times the cost of a standard warehouse of the same size. And so it's important that while there is you're doing the value analysis right in terms of to select sort of the compute primitive and warehouse type that makes the best sense from a price performance perspective for your specific use case. The other query that I'll run here is a query that will show me the top 10 offenders, so limiting by 10, in terms of the queries that are spilling the most amount of data to both local storage and to remote storage, which is AWS S3 in this case. So this should give me 10 queries that are the biggest offenders um, in terms of data being spilled to disk and to S3, which again represent candidates that could potentially be moved to Snowpark optimized warehouses. I'd be remiss not to point out that at Snowflake, we also expose a number of metrics such as warehouse load and this brand new metric that we call warehouse utilization, which is in private preview. And using a combination of, um, of the values for utilization and load over a period of time, um, it can actually provide useful and actionable signals for you to right size your compute. So what I have here is a collection of some common patterns where we highly recommend right sizing or using these signals to right size your compute. I won't get into the details of each one, but the high level idea is if your utilization is low and you're not seeing queuing and it's low to a point where it's below 50%, that is a useful signal to actually downsize your warehouse by a certain size. Similarly, we have signals in terms of what you need to do or what you could do, increase the amount of concurrency based on signals such as queuing, based on the number of clusters, etc., as well as certain patterns where you can move certain spiky components of workloads to a specific new warehouse while the stable part could be on a different warehouse, etc. So again, we have a large amount of documentation here that uses both the warehouse load as well as utilization metrics to provide you actionable guidance in terms of right sizing of warehouses. And the blog post that I alluded to earlier also has some content on this. Now, that forms an overview of some of our core capabilities. But last but not the least, there's one last thing that we have, which is something that's brand new that we have here, which is a completely overhauled, which is a private preview of an overhauled cost management interface. So this is an admin pane experience that gives you a one-stop shop that visualizes all aspects of your spend, including starting with your contract value, looking at things like most expensive queries, drilling, being able to drill down into warehouses, into specific tags, etc. The other super interesting part here is what we call cost insights, which is essentially a screen real estate where we as Snowflake surface insights around low yield spend or suboptimal spend, where we think there are low hanging fruits for the purposes of cost optimization. So things like egregiously underutilized warehouses, or things like tables or storage artifacts that haven't been touched in prolonged periods of time, is things that we will surface here. And this is again in private preview, and we're working hard to ensure that we roll this out to as many customers as possible. We're also iterating on the feedback. What you see here is a sneak preview of what the screen layout looks like as things stand. So with that, I want to wrap up this presentation. At Snowflake, it is our endeavor to ensure that all of our customers are getting the best bang for their buck for their investments into Snowflake. The tips and tricks and capabilities that we went over provide an overview of the capabilities that we offer to you to ensure that your compute is right sized and your spend is as optimal as it can be so that you're getting the best bang for your buck on Snowflake. Thank you.